All right, in this problem, we want to find the points on the graph of this function f of x defined by that cubic where the tangent line is horizontal. So the slope of the tangent line is given by the derivative of the function. So in other words, we want to find where f prime of x is 0. In other words, where the slope of the tangent line is equal to 0, since horizontal lines have a slope of 0. So we need to find the derivative. Now, if you know the chain rule, this is fairly straightforward to differentiate. But I'm going to work this assuming that we don't know the chain rule, which means we first got to expand f of x. And we'll multiply it all out, and then we can differentiate it using the power rule. So first I'm going to distribute the 12 to get 12x plus 84. Then we need to expand this x plus 7 cubed all the way out. So let's write it as x plus 7 squared times x plus 7. Okay. Then I'm going to bring that down here actually for space sake. So we have 12x plus 84 minus, all right, the product of x plus 7 squared and x plus 7. So x plus 7 squared, if you FOIL that, you get x squared plus 14x plus 49. And we still have to expand that with one more factor of x plus 7 there. And so we get, let's come down here. So we have 12x plus 84 minus, now the x squared times x is x cubed. X squared times positive 7 is plus 7x. 14x times x is positive 14x. 14x times 7, so for these kinds of calculations you may need a calculator. For the 14 times 7, we get 98. So that's the 14x times 7 is positive 98x. Then these two terms come to plus 49x, and then 49 times 7 is 343. And lastly, what I'm going to do is distribute that negative out right there and also combine all the like terms as we go. So the highest power I'm going to have here is this x cubed. So our first term will be minus x cubed. Next would be x squared, which I think I didn't write. Yeah, that would be 7x squared and 7x squared, 14x squared. I just left off the squareds there. It's okay. So that's 21x squared times that negative is negative 21x squared. Okay, then we have several x terms. We've got, that would be negative 98x minus 49x and a positive 12x. Let's do that on a calculator. So 98 plus 49 first. And I'm going to make that negative, and then I'm going to add the 12 from the 12x at the, oops, not 14. I'll just do minus 2. So we get negative 135x. And then the constants, we have 84 minus 343. Comes to negative 259. Now, none of that involved the derivative at all. That was just expanding the function. But now that we have that, we can differentiate using the power rule. So we get f prime of x is negative 3x squared. Bringing the 3 down, decreasing the power by 1. Bringing the 2 down times the 21 gives us negative 42x to the first. The derivative of a constant times x is the coefficient, so negative 135. And the derivative of a constant by itself is 0. So there's the derivative, and we want to find where the derivative equals 0, so we're going to set that equal to 0 down here. And then we need to solve. So that gives us a quadratic, which may or may not factor. It's hard to say. I don't think I can factor 3 out of everything, but I do want to go back and double check this, the 98 plus 49, just to make sure. There, so let's do 98 plus 49 again. And let's see, that should be negative and then plus 12. So negative that plus 12 is, yeah, negative 135. And All right, so I don't think that's divisible by 3, so therefore I cannot, oh, it is divisible by 3. Nice, we can take a -3 out of everything. That will work. Oh, yep. Okay, so pulling a -3 out of everything, that will maybe help us to factor. So let's see, this is equal, or actually I don't need an equal sign there, and I'm now solving this quadratic equation. So I'm going to take a -3 out, leaves me with x squared. Let's see, 42 divided by 3 is positive 14, so x, and then that was 45 there. We took that 3 out. That's equal to 0. Now if we just divide both sides by -3, that constant goes away. So let's see if we can factor this. 45 breaks into 9 and 5, which do add to 14, so that's going to work out pretty well. So we get x plus 9 and x plus 5 equals 0. So that has solutions at x equals -9 and at -5. So those are two x values. We would put the smaller one here, -9, and the larger one there, -5, at which the slope of the tangent line is horizontal. Now, we'd also need to go find the corresponding y values. So right there you would just find f of -9 and f of -5 to go there.